Okay, so I only do one base class inheritance. The reason is because when you have more than one, it's nobody knows what's going on. A source symbol has a C hash as a base. What that means is the C hash is the base class gets placed right in front of it. So if you have two base classes, then which one comes first and how does that work? So I only have one base class because I want it transparent, and that's obvious. I don't want multiple base classes. The public and private is just for the help. Here's the deal. In 1999, I had a program that accessed the parallel port, and it was a device that reprogrammed some chips. And when XP came out, they blocked access to the parallel port. They blocked access to ports. And I said, oh, fuck. So what I wanted is a machine that was 100% open access. So I have absolutely no blockage. Everything is accessible. Nothing is blocked. And I used the same logic. I don't want public and private. Like, I don't want my system variables off limits. What I want is I want people to if they want to look at the task record, class rep D. Class rep D is dynamic, and it knows by the pointer type what class it is. So this is a dynamic shot of the class record. It's updated 30 times a second. So I can come over here and I can move the top window, the top of the window down 5 characters. I can move the window left in 4 characters. So I want everything accessible. A normal programmer tries to keep you out. Like, let's look at for example, cur directory. How about this? This is the task record, okay? Let's look at cur directory. Curdir. We're in the kernel directory, okay? This is a pointer. That's a 9.8 and that's an A0. So curdir is a pointer. So what we have to do is we free fs curdir, and then fs curdir equals string new compiler. So this will allocate. Okay, look at what directory are we in? We're in compiler. Do you realize what we just did? Now let's go up here and look, and it'll say compiler. Curdir. Uh-oh, what the I don't really know what's going on there. That's not what I expected. Maybe it doesn't like dynamic. Let's do it again. I just redid the, I think it was looking at a pointer. There it is. Okay. It was a pointer. The pointer was still the same, in the and it was okay. So we just, do you realize what we just did? We just hacked the kernel and we changed the current directory. Now you have to know what you're doing. You can't just do this stuff and get away with it. You have to know what's, but you can find out. The kernel is only the kernel is only 23,000 lines of code. If you look at it, the scheduler is right here. You could actually understand this without too much trouble. This tells what it saves when it saves a task. If you have breakpoints, it saves breakpoints when your task is swapped out. When your task is restored, it puts back in breakpoints. So breakpoints are assigned to a task. Here's the breakpoint stuff. So I guess we'll talk about graphics. So this is supposed to document the graphics. It's not a very well, anyway. So there's a task called the window manager on Core 0. All applications run on Core 0, and if they want slave cores, they put tasks on other cores explicitly. So everything is Core 0 pretty much. The Atom task is the executive. His memory is global, kind of. Everybody's memory is global, but let's say you put the wallpaper in Atom's memory, then it won't die. If you put the wallpaper in your memory, then when your task dies, the wallpaper is messed up. So it has to be an immortal. That's why you would put the wallpaper associated with Atom. And anyway, Atom has a heap. You can allocate off of Atom's heap if you want memory. That's kind of like kernel memory. It's not. Well, anyway, it's the closest thing. So there's a window manager task. This runs 30 times a second all the time, and it updates the whole screen. And this shows the order that it updates stuff. Well, first of all, only tasks on Core 0 can have windows, and they can each have one window. So what you do is when you want a window, it makes a new task, and we can do yes or no. Let's do no, and we got 0. Yes, we got. So that's a new task, and it's a child task. Like if it's modal, that means that that means you can't select the parent. You can't make the parent focus because the child gets the focus. Like if you try to click this one, it won't click it. You have to click this one. Oh shit. Anyway, so so the window manager draws the screen 30 times a second. First, it generates the text layer. A lot of people think there's B800 memory. If you know what I'm talking about, you know what I'm talking about. A lot of people think this is text mode, but it's not text mode. But it is similar because we do have an array. If you hit F1, this talks about the text layer. Bits 0 to 7 are the ASCII. That's just like B800. 8 to 11 foreground, 12 to 15 background. That's just like B800. But here's where it gets interesting. You can shift each character off of the grid by an X and a Y. you have a blink, an invert, a select, and an underline. Those are flag bits. So watch this. Let's say Control Shift. I forgot what the keystrokes are. You just have to look them up. Insert subscript, and then insert. It toggles the subscript. Okay, so now we have some characters that are off the grid. So it's they can only be within 8 of the original. If you hit Control T, there's a command SY. I think it used to be scroll. I don't know what that stands for. Scroll Y. Scroll Y 3. Scroll Y 0. Okay, so it can be a number from 0 to 8. You can scroll off the X as well. So that's for you see how these are scrolling. That's a marquee. Well, so there's a text layer. It draws the text layer. Then it goes through all the documents in task 0. Okay, the order of the tasks on core 0 determines the Z order of the windows. That's the front to back order. Starting at the window manager. The window manager is the wallpaper, and then I don't know if it's forward or backward. The Z order. Anyway, so the Z order that's only on task. It's only on core 0. The window manager, and then the root Atom. Atom actually has a window, believe it or not. The Atom task has a window. You can't type in the Atom window. Control B gives you a border. If you maximize, you might want the border. So this is the Atom task up here. He just stays here. He's like a server. You can make him. You can make tasks servers really easily for client and server. There's some support. Inter-process communication is easy. Anyway, so let's say, hey Adam, why don't you beep? Okay, anybody could have beeped. Hey Adam, print hi. Do you understand why I have to do it this way? Uh-oh, that's not good. What happened? Character return? No, it doesn't need a character return. Backslash quote. Hi, backslash quote. Semicolon. It doesn't need. It does need a character. What is your malfunction? It missed one. What the fuck happened? Okay, anyway, so you can, I made an Atom log. Okay, so that's just that. So maybe you want to log, but there's actually a better way. There's raw print. Then you give it milliseconds, 1,000 milliseconds, and then this is a printf. Comma. So raw print. Wait 1 second. Keep it on the screen a second. Print what, and then %d. And this is a printf with you can have multiple. Okay. Let's keep it on the screen 10 seconds. Okay, so this is a non-windowed direct to VGA print. So the other cores don't have windows, and sometimes you have a task with the window hid or something, and if you're debugging and you just want, you can do it for a second. Or the reason it goes away, why do you think it goes away? I'll tell you why. Because 30 times a second the whole screen is being redrawn. That's sort of a lie, because it has a cache, a low level memory cache, but we don't have back. Most other operating systems have bitmaps that they keep track of for the window, and they try not to redraw and stuff like that. We redraw everything. Do you want to know why? Well, because the worst case that you have to handle is a video game. And if you're doing a video game full screen, it doesn't do you any good to have rectangles that are not redrawn. You want to redraw everything. Fuck it. Let's keep it simple. Redraw everything. So there's that text layer. When you each task has a standard in, standard out sort of. It's not called that. It's called. I'll explain that in a second. But there's a document for the. There's one document for the border, and there's another document for the client area. The window manager goes through all the tasks, it redraws all the documents, and what that does is it remember there's a text layer. So first it displays the old text layer from the last cycle, and then for the next cycle we set the new text in the it's kind of like the B800 memory. It's like we're writing to the B800 memory. And then the next time it comes back around, it'll be the new text. So on top of the old text, it draws. It's kind of out of sync, but it doesn't really matter. It draws. It does a draw it callback. This is where you put your graphics, and then there's controls. There's only a handful of controls. I sort of was copying Windows terminology. The scroll bar is a control. You can make a slider. You won't be able to see this, but I can. There's a control. It's sort of overrated. There aren't really very many controls, but there's buttons that you can make. So there's a queue of controls that goes from first to last, and then finally there's a persistent layer, and then a mouse cursor. The mouse cursor is drawn in the final update. The persistent layer is just a crazy transparent layer. If you say GR circle, it'll default to the device context of the whole screen, and then 100, 100. This will put it on the persistent layer. The other layers are redrawn every cycle. So the persistent layer is it's kind of for beginners. Rectangle persistent layer 100, 100, 100, comma 20, 40. Anyway, so you have to clear it. It's called the device context. DC fill. This will fill it with transparent. Or So it manages to do that. It does all that work, and we're only at about 4% CPU. But it gets expensive when you start doing 3D graphics. You will quickly run out of CPU doing stuff. As a matter of fact, just for example, let's go to my After Egypt, where we talk with God. This scene here is actually pretty hard to do. You can't get too carried away. As a matter of fact, I had to draw my trees as vector instead of bitmap. When I made them bitmap, it was just too hoggish. So the trees are vector. It turns out that the number of pixels is probably the best estimate of how much work. So basically, triangles is not the issue, it's the number of pixels. Well, anyway, this is God talking. Plenty ejected, foundations ageless, graded, pallid, roamer, chimps, cantilevered, crane, depth, Hesperus, crabby, yank, carnival, binomials. So I have a root locus. Anyway, so there's a if you go to the graphics demo, there's a pole zero plot, not a root locus. Anyway, so this is done with, we changed the palette to give us shades of gray. These are poles and zeros. It's having to evaluate a complex function for every pixel on the screen. And you can look at the phase. You click the right mouse button and it's the phase or the let's look at the phase. That's the phase. Anyway, so there's support for changing the palette, but there's a big problem. If you change the palette, what's going to happen? What's going to happen over here? If you change the palette, what's going to happen to this other application? Well, it's messed up. So you can only run one application at a time if you're changing the palette, or it'll look bad. There's nothing wrong with it. It's just I avoid it if possible. A person could enthusiastically change the palette, but I really try to avoid that. Like I even draw, like, did you know the Commodore had a carefully chosen palette? This palette is just the most natural, but if you look at the palette for skin color, oh, damn it, I don't want that. Well, there's yellow and there's brown. There's not really a flesh tone, at least a white man flesh tone. So you could change the palette and add that. And if you want to see the palette routines, we can start talking about the graphics routines. So these are your standard. The interesting thing is that they're not done with floating point. Some people think it's because I don't have a floating point processor, but it's actually because it's faster with the integers. So I do my Now this is kind of wasteful, but I have a generic circle and a generic line, and these callback for each pixel plot. This is where it's doing fixed point integer math to draw the circle, and then it's doing a callback. You see, you pass the plot into the circle, and then it calls the plot. Okay, so the GR circle uses that. So it's anyway, a little bit of overhead. So rectangle, you should use that instead of flood fill. Flood fill is slow. Rectangle's faster. You can make bitmaps, device context bigger than the screen. Technically, flood fill's going to hit a problem with the stack. It's a recursive. Actually, it's not recursive. It allocates an array because the stack is probably not big enough. It's not recursive. It's a state machine. That's basically, it's like recursive, but it's done with a state machine. The system stack for each task is I think it's 128K. You might say, why so little? Well, there's an interesting thing, and that's that if it's a fixed size and it's not infinite, then it really doesn't matter that much. You might as well make it small. Anything that's big you should do with the heap instead of the stack. So you can't really be doing unbalanced binary trees because you'll overflow the stack. One thing I probably should add is a data type for red-black trees or AVL. I should add a data type, but it's not. There's no hurry. You can always do it yourself. That was the beauty of the Commodore 64. All you had was the ROM, and it's very nice. I don't want any third-party libraries because that first, it's going to create a dependency hell, and second, it's defeating the purpose of the 100,000 line limit. The 100,000 line limit is supposed to let you master it. You're supposed to see the light at the end of the tunnel. This is the help index, and you can learn the whole thing. And that actually it should be you should know it and be comfortable instead of being out in the ocean of a thing that you don't even know how big it is. You don't know anything about it. You're just lost in the ocean, and it's really deep. It has B-splines. That's fairly standard. You can figure that out. Blot is, I think they call it blit. I call it blot. Oh well. That puts I did all this by hand. We don't want to use a GPU because we want it transparent. We're not really after, heck, we're using 640 by 480. We're not really, results are not important. That's not quite true. Anyway, some of that is because you don't want to be doing art. So here's palettes. You can play with the palettes, get and set colors. This is kind of crazy. The color type. I'm a little bit embarrassed at how fucked up this is. It's not. Colors start getting interesting. Okay, so in Windows you have a raster operation, and we have XOR and equate, and we have a collision that will detect collisions, and we have a no, I don't think mono is mono a I think it might be a raster operation. Anyway, so there's the raster operation, if you dither, then you have two colors, and you might have a probability. It's kind of like quantum mechanics, probability density function or something. That's how my dithering works. I'm serious. I use a probability dither for there's a threshold, and it uses a random number. If it's above the threshold, it's one color. If it's below the threshold, it's the other. It's a random number evaluated over and over and over for each pixel. So there's a depth buffer. That's the standard way that you do hidden surface removal or blockage. There's three-dimensional and then there's two-dimensional. So the all of the three-dimensional routines are like deluxe. The two-dimensional are simple. The three-dimensional are deluxe. So the three-dimensional have a transformation, and they have a pin width that works. The two-dimensional doesn't have pin width, and number 0 doesn't even have clipping, so it's like deadly dangerous. 0 doesn't even have clipping. That's like raw. 0 doesn't have clipping. 3 has clipping and pin width. So line 3 is 3 dimensions. Line 0, line by itself is just a pin width of 1, and it has clipping. Anyway, these tell what they have. You'll quickly get to see 3 is deluxe. Without a 3 is not very deluxe, and 0 is dangerous. So I support BMP files from Windows. We want them to use our GRA files. It's a replacement for BMP. We want Windows, and they need to make Paint support our GRA files, and GIMP has to support it. Somebody said they did the code to make GIMP support it, but you have to compile it yourself or something. We want it in the standard distro. Graphics screen. You can do a screen capture and capture to a bitmap if you want. So the mouse cursor, you can change the mouse cursor. There's a lighting, so the color is kind of weird. I'm embarrassed by the color. You either have, so if you have that probability dithering, you either, now if you have a light source, you have to, well, this shows the light source and how it does it. Sometimes you have a surface with one color on one side and one color on the other side, and if that's what you have, then you have half as much color. When you do a if you do a sprite, if you do a Control-R sprite, and then you do mesh, then you hit C for color. So there's either single-sided full range or single-sided half range. So what this means is, well, I try to explain it. Single-sided means both sides are the same color. Double-sided means the backside is darker. Half range means 0 to 7. I tried to explain what this means. I don't know if this makes sense. That means you go, well, I don't even. You see how there's a light red, a red, and a black? There's three: light red, red, and black. And either you go from black to red, or you go from black to red to light red. So there's either 2 or 3 colors. So full range means you go from black to red to light red. Half range means you go from, that means you either go from black to red, or it means you go from light red to red, or I don't know what the other one is. Light red to red. I guess if you do light red, it goes to red. Anyway, so it's. You know, I really hoped everything would be simpler, but this is definitely one area where it's more complicated. You know what I should do? You know, I thought about this. If I presented a RGB and then I did this internally, except that's not going to quite work. Oh well, God said 640 by 480. Let's see what God says. Ineptitude, generate carousal, theoretical, knife by wrenches, concerting, sacristy, icy, artist, child-proofed, Icarus, angle, guacamole, thronged. So, so there's sprites. I didn't show all the sprite things. So, color. Most of the graphics work with the integers. Okay, device context. You can save it to disk. GRA is the TempleOS graphics file format. It's not really used much yet. Anyway, screen capture. Where's the sprites? Okay, so there's a transformation, a 4x4 matrix multiply. The reason for 4x4, I explain it. Anyway, where are the sprites? Here's the sprites. So you can rotate around the X, around the Y, around the Z, or you can have a matrix that rotates. And there's 3 and 3B. The reason for this is if you have a transformation that is, let's say you have an isometric transformation. So when you draw, it comes out isometric. Well, there's a coordinate system of where you put the sprite, and then there's the coordinate system of the sprite itself. The sprite has its own coordinate system, and basically one of these uses one coordinate system and the other one uses the other. I don't know how to explain it. The sprite has its own coordinate system, and when you start doing a three-dimensional transformation, it becomes inconvenient using the sprite. You'll see. When you try it and it doesn't work, you'll look for how to fix it. Okay, let's see if we have some questions. Okay, let's see if we have some questions.
Okay, let's see if we have some questions.
Yeah, exactly. That's how you end text mode. Some people try to spread rumors. Somebody said it was 32-bit over on 4chan. They said, no, it's 32-bit. He's going to 32-bit and using BIOS. No, fuck no. There is a 32-bit BIOS, but that's for PCI. I don't really use that, but it's not the point. So, out of curiosity, if you might try this if you want to have some fun. There is a text mode version. If it doesn't, it's possible that it wouldn't have 640 by 480. I think that's pretty crazy, but when you do make OS drive boot install, this is how you remake the kernel and compiler. Okay, we want the C drive. We want to start numbering at the C and D. C. We want to probe. Start numbering at C, then D. Now we want the hard drive number 4. Now we want, okay, that's all the drives we want to mount. We should mount the RAM and the CD-ROM, but we don't care. Disk cache size, we want the default. Now this is options. You can set it in if you want to debug memory, like by setting it to a known value. There's some memory debug things. You can turn off multi-core with no MP, no multiprocessing. Then look at that, there's text mode. Then there's a couple weird ones. Anyway, so text mode, if you really want to, if it doesn't have 640 by 480, it'll do text mode. Okay, so that's our option we're compiling into the kernel. So this only takes effect if you do an actual reboot. And then one. What the truck? Oh, holy shit. That's a new bug. I just changed the VGA text mode, of course. Okay, now we have something to do. We can fix it. Okay, so let's reboot number 2. This is easy to fix, pretty easy. Okay, first we recompile with the normal options. There's the normal options that I use. And then we reboot C. C is my master, so I do all my work on my C drive. Now let's say find VGA alias. Okay, so I went ahead and fine. VGA text alias. now I just have to look for VGA text. VGA text. VGA text. Okay. It's in a bad place. Okay. Find VGA text. There's a lot. Why is there so many? Okay, start. Oh. That's for, it prints a couple startup messages during reboot. Okay, if it's text, well, the new, basically everywhere this is, we substitute. What is this? Oh, and it's not ×2 anymore. You understand why? Because pointer arithmetic. We did do that, did we not? We did VGA text alias. We don't do it ×2. That's not very transparent. That's gonna confuse the children. Uh-oh, shit. How is columns? What the truck? Oh, what? Oh, you don't suppose? Okay, let's back off of this. I'm a pussy. Okay. I should answer why. Okay. We're going to make it a size 1. Find VGA. We can just replace it. Let's fucking replace VGA. Okay, memset init, yes. Destination, yes. Boot HD, no. Boot MD, no. Display, yes. 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 Skip. Yes. Skip. Skip. Okay. Now, rows times columns times 2. The least you could do is high resolution text. Now, isn't there there's a big text and a little text. I want to do this tab. Now the one that confused me, this one, what the fuck? Oh, I think it's a multiply by 2. This is for scrolling when you're in raw mode. We take text columns times. This is for the bottom. Copy. Copies that scrolls the screen from bottom shifting up. So this is one. Is this a bug? Why is this not times 2? Let's see what happens. Bug. So the top, oh, the top line. It's in the raw mode. Okay, I think that's a bug. Let's see if we have. Okay, so what line number? That's display 47. Okay, so make OS drive boot install C probe 4 enter text mode. You know, with these lists, it can handle as long as it's not ambiguous. You can. That's a Ticketmaster trick I learned. Watch this. Let's see. It didn't find it. We stayed in. As long as it's not ambiguous. Like if we say. Oh well, You can use abbreviations or short. Okay, now reboot. So if my theory is correct, oh, what the? Oh, I hate when that happens. Damn. How did I fuck that up? It looks the same. How did I screw that up? I'm not a shitty programmer. That was easy. How did I screw that up? How on earth did I screw that up? It's not that bug. That's... Let's... You think B800? It's halfway down the screen. Oh, what if... Okay, let's go to the source and see what is your major malfunction. What the fuck? GR update text mode. GR update text mode. There it is. We didn't change that. All right, let's see. We did change it. try it again. So there's a an alternate way. Oh, look at that. That could be it. No, no, that's not it. Yeah, no. Okay. Reboot. Compile. Reboot. Text mode. Text mode off. Uh-oh. I must have done that on the other machine. That's really dangerous. The other operating. Text mode. Reboot. So it's halfway down the screen. So it's a 2. So if I scroll up, can't believe it's got fucked up. Is this okay? The color is not scrambled. What if it's going by I must have done something to ruin this at some other point in time. Okay. Uh-oh. Okay, let's go to Drive C. Okay, well, fuck it, let's go see what happens if we, should be obvious, but it's not obvious. It really looks like my VGA text alias is not correct. Did I change the wrong version? That would make a lot of sense. God, by some miracle. there's a cache. Oh, we're reallocating. That's it. Okay. So we're reallocating. That would do it. Okay. What if we put it first? Okay. Damn, I was freaking out again. Okay, so compile, it's text mode. Holy shit. The scrolling. What if the little motherfucker changed it? Let's just see what happens. What's gonna happen? We do Asia. What about the initialization of the text? It's not text globals. No, okay. What if we double? What the fuck? You think, what if it runs off of physical memory? What? That's nonsense. Off. Okay. What the fuck? It has to be, you know, we could allocate a second page. That wouldn't be a problem. What if there's a cache? I bet the cache is not correct. Okay, so there's a okay, so is there a cache? Let's always flush and see what happens. If, as a matter of fact, I think this should not have changed. If flush. Text cache. Destination 2. Okay. It was right for the first part. But in the wrong place. It's a 4 instead of a 2. It's a 4 instead of a 2. That's interesting. It's not quite a 4 instead of a 2. Or it could be an 8. It could be an 8. It's probably an 8. Okay, so it's another, something else. Drive C. GR. It's when we're filling in the text layer. What is text base? U32 source base. What the heck? Let's just try this. Colors are right. What about little Indian, big Indian? No. The colors are right, but the symbols. Oh, that's the source base ones. What? Now we're skipping. Black is the upper. You know, what if some of my users are in text mode? Okay, so we had a black column every other one, but the U16 destination. What about VGA text cache? Fine. The symbols are wrong, but the colors are correct. That's just crazy. What the fuck? And it's halfway down. The cache. What about the color plane bit? The color plane? What if the color plane bits? And it's half. What if I'm, let's see, what am I doing? What is the map mask? Text background, text foreground. Update text background. Update text foreground. Okay, that's graphics. Update. What does that do? Maybe that'll do something. What if it requires 4K page tables? Let's say fuck this. Let's go to home. Kernel. Let's go to drive C. Well, we can certainly write to the other one. No problem. That's fucked up. It looks like the let's power down. I think we corrupted the VGA. Font? Did we rewrite the font? What the fuck? I don't think this is gonna help. But let's try it. Okay, so stop. Let's turn this off. Hey, it's different. I told you it was. Sort of, is it different? Maybe it's not. Hey, it's full screen. There we go. Okay, cache. Is that? Is this a cipher? Is this a cipher? Change log. Reboot RAM. Is this a cipher? What's the kernel? Let's see, Control T. Hold down. Oh, you know what this is? This is write through versus cached versus uncached. Okay, quit. Reboot. That's really weird. You think that's what it is? Has to be something. Let's. I'm doing a merge. Wait, let's abort. What the truck? Abort all files. Oh, that's what I did. Okay. Okay, now that was a bug. But it's only in, why don't you fix the bug? Okay, let's quit. Looking around. What are we on? D. Drive C. Through. In. Display. Just call it ×2. What if that's it? That can't be it. How did that get changed? If it was wrong. Okay, now it's not centered. Can we center it? Yeah, okay. So I think the cache is the problem. It's cache, writing it out. Cache lines. Okay, so in the manual, architecture 3A. Okay, so we have 2 meg. It doesn't like, okay, where is it? Segmentation 32E. Okay. We're looking for I think there's a separate, there it is, page translation, there it is. Okay. Okay. Page directory, page table. It's basically a page directory. Let's see. Formag. They don't really, I don't think they. Okay, 2 meg. Okay. Uh, 4K pages. PA. Two meg. Okay. So, let's see what, damn it, stop it. Drive C, kernel, memory, physical. Okay, I think I probably set it to the wrong value. That's what I had it set to before, I can swear. Okay, 1.8F. So we got 1G for granularity, 1.8, we got 0D, so we got G equals 1, D equals 1.8F, D equals 0, A equals 0, PCD equals 0, 1.8F, PWT equals 1, US equals 1, read, write equals 1, P equals 1. Okay. Here we go. Okay. So the G flag is a granularity. No, it's global. D, dirty. A, accessed. PCD, cache disabled. We have it set to 0. Right through. PW, we have right through set to 1. User supervisor set to 1. Read write set to 1. Present set to 1. Okay. Okay, we have user. Oh, we have two mapping to the same place. Holy shit! Holy shit, we have 2 pages mapping to the same place. Damn. I'm glad I figured that out. I was freaking out. Okay. I'm lucky it worked at all. How is it working? The other one is cached, I guess. And it never writes out. Okay, let's page level right through 1. I don't think I would have figured it out. Okay, well, we can disable the cache for one thing. That's the only thing we can do. What is that? PCD, page level cache disable. Bit 4. That's, yeah, we don't want cache. That's bit 4. So we had 1. We had, what did we have? We had 180. We had 1G8. PCD. We want a 9. We want a 9. Okay, let's just do it. 19F. Let's see if it runs any slower. I'm surprised it worked for regular mode. Damn. Maybe we do it so fast. Okay, it doesn't seem to be a problem. Now we, please, by some miracle. Oh, it's not liking that. What if we mark page what about real hardware? I have it on real hardware. It's working. So we want the low memory to stay. Don't update. What if we update both? Fuck it. No. Yeah, we can update both. That should work, actually. Why won't that work? Update both. So I have an alias and I have a real one, and the damn, what keeps it from why is the main mode, why is the graphics mode not a problem? That's the question. The question is not why is it broken, it's why did it work? Okay. VGA text alias destination. Just do it. Okay. Okay, Control F, destination. Okay. 3 destination alias. Okay, well. The color, no, the color's not quite right. It's close. The color is close to right. So I have 2 pages mapping to the physical. I'm gonna get rid of what I just did. Okay. Since it didn't work, should have worked. What if we change it each time? Like, It's not cached. What if we can get rid of the cache? What would that do? What if we see. And okay, it's the cache problem is gone. So that's our cache. The color. It's a cipher. What is the key to the cipher? Oh, let's do Control-Alt-A. We are writing to the font. The font has been shifted. The font is... What if we copy memory from low to high? How about that? Let's do that. Okay. Boot. 2. Okay. So let's go to Sprite. Damn, I never would have figured it out. Okay, let's... Oh, let's do number 2. I almost forgot that. why would it be? Now I changed. I'm pretty sure that was a bug. Okay, so now we want to okay. Now we go to kernel. Oh, the other answer. Okay. So memory set. We should do this all the time. Memory copy. VGA. Page. 0. Alright. That's 60. That's, what is that? This is dangerous, actually. Shouldn't do this. Okay, that's 64 times 2. Faster. It's possible that with cache disabled, it's different. On real hardware, I thought it was faster with write through, but on this, I can swear it's faster. Let's see. It's the same speed. Okay. Now reboot. No, it didn't work. Control-Alt-A. Oh, I'm an idiot. Of course it's not, well, let's see. That's 16. cache. I think this is my bug. I think this is my bug. It worked at the beginning. Did it? It worked at the beginning. You idiot. This has got to be my bug. Oh, wait a minute. Let's see what it does on real hardware. Like, let's make it last check. Okay. Okay, well. Okay, so I discovered something.